Hello, students. These are now two recordings. This is the first out of two, which relate only to two diagrams from the lecture slides. And this is the first diagram, which is actually the first link on that particular slide in lecture notes, which I would like to debate with you. And let me now try to share the screen with you. This diagram has been chosen out of many on the internet, and there are two reasons behind this choice for this one. The first reason is it's a very interesting diagram, which is almost close to the UML philosophy. That means it's by no means perfect, but it's almost impossible to find the perfect diagram on the internet, exactly, which does follow what UML semantics recommends. It's all recommendation. And I didn't copy any content, any text around it. I just copied the diagram because it has quite neat layout. So the top row of every sequence diagram is a set of objects. Set of objects which are abstractions taken out from use cases. Now, here we could see that the first object is leave request entry page, which actually means that that's an entry page of the web application, something like that. And the name of this entry page is leave request. This is obviously a web application which allows you to request your leave as an employee working for a company. Okay, so this is obviously a user interface. The first object is a user interface, and this is more or less the only type of objects you can put on the leftmost position of the top row of sequence diagrams. We always start with the object which is related to interfaces, user interfaces. Do you see this object has a very, very long lifeline? This is this very tiny, long line, thick line. Amber color, I think so. Light brown, something like that. So this user interface then sends a message, which is called create leave request. It's not exactly what UML would ask you to name your message, but it helps us to understand that probably an employee, which is an actor, presses something on the screen, entry page, main screen, which means create leave requests. And then this message, actually, in other words, explanation that I pressed something on the screen button, which is called create leave request, results in leave request control objects to receive it. This is according to UML. So the second object in this top row should be control objects. However, there are two issues here. Employees save leave request and submit leave request. Communication between employees and user interfaces are not allowed to be shown according to UML. So there is no way that you can have an arrow between the employee and the object, which is the first one, user interface. You can have only a line, which means that an employee or an actor initiates the functionality which was behind the use cases and which is the base of developing the sequence diagram. So here, save leave requests and submit requests are not supposed to be there according to UML, but it's there. It can be imagined that actually the initial interface, initial screen might have two buttons, create leave request and submit request as a button. So these are the two things that you can click on or press. All right. So user interface sends a message to the leave request, and I suppose that this is to be a computer program. However, I doubt, because if it were a computer program, then leave request is supposed to call data to calculate this leave request, or to compute leave requests, or to process leave requests. But nothing happens after that. I suspect that actually leave request is some kind of data object, which is called leave request, or like a form which you create because somebody pressed the button on the homepage. Well, this is just my speculation. This is not what UML would like you to do. UML would like you, after entry page, that you send a message to a computer program. And now I can see where the computer program is approval workflow. Why? How do I know that approval workflow object is actually representing your computer program? Because this is what UML wants you to do. The first one is user interface object at the top. The second object at the top is a computer program that will take messages from the interface and do some calculations or computations. Why do I know that? Because in 50% of the literature, instead of control objects, people use the word workflow. And in one of the best books about Java technology and component-based architecture, workflow actually completely replaces word control object, but in UML, unfortunately, they stereotyped it into control. So you have to handle this. It's either workflow or control, but it is nothing else but a computer program. So the third object from the left, approval workflow, is actually your computer program. So I hope from now onwards, the rest of the objects in the top row are data objects. So schedule is data, approval is data, activity is data. Okay, we can just guess that it's data because we understand the English language. So actually, apart from drawing an arrow between the actor and the user interface, which is not allowed according to UML, and apart from having leave request, probably data object immediately placed after user interface, this diagram is all right. This diagram, then, if you just correct these two things, put leave request somewhere else behind approval workflow, then you have a perfect sequence diagram. These messages are very easy to read. Computer program approval workflow will check employee schedule. So it will get back date when the employee is available. And all employee schedules, I believe, are stored in some kind of database or some memory, persistent memory, when you can always retrieve it. Then the same computer program create leave approval from the request, leave approval. It goes to the leave approval, either database or something similar, and creates a record there. Then creates a new leave activity. I don't know why, but that's something which is relevant for that company. So then you create records inside the leave activity. Then you go back to employee schedule and add activity into that schedule. So employee schedule has been updated. When the computer program called approval workshop finishes, it displays on the screen a response with leave approval. It places on the screen, which is called entry page. So this is how we draw sequence diagram. I did choose this one because it's such a neat explanation how approval workflow computer program needs 3, actually maybe 4 different types of data, because I will put leave request completely on the right side and change these messages a little bit. These are these big errors? Well, this is not following what UML people told you to follow. Is it an error? You can't say whether it's error or not. But there is one very, very important thing. User interfaces today are mostly, not only today, even 10 years ago, 20 years ago, are mostly programmed in markup languages, and they have no computational power. They are descriptive languages which describes the layout of the screen, colors, fonts, and stuff like this. If this is a future software component, this homepage, and if we really program it correctly with some kind of XML or Java server pages, in that particular case, this user interfaces should not be able to do anything else apart from sending a message to a computer program, because they cannot compute. no computational power. However, there are technologies today and tools which will practically deploy all these objects. These are not C++ objects in real terms. All these abstractions in some other languages, not in object orientation. For example, approval workflow might contain only SQL statements, nothing else. We don't know, but it's very likely that it will be a web application with SQL in the background. Not a single trace of a particular heavy C++ programming behind. All right. So this is about this this example of sequence diagram. So from approval workflow on the right, it's quite clear. And this is what we should be doing in this subject. We finished short of implementation, but this is now straightforward, ready to draw the software architecture of your application. It's not ready yet, but very likely that it will contribute towards a conceptual model. And this is why sequence diagrams are very good for that. Much, much more useful than class diagram will ever be. Okay? So this is all now for this first sequence diagram. I'm now going to have a separate recording for the second sequence diagrams. Let me see. Let me just quickly display these links. So this is, I've just covered the first link. It is from Concept Draw consultancy website. It's a very, very old example. Sorry. I will stop sharing now and make another recordings for the second link for that diagram. Thank you for listening. Bye. Oh, I should stop recording.